But let's finish up this thing on page 11 first. So if I kept good notes, on page 11, we need to do number 3. Would you read that? All right, so there's my unit circle, not all labeled for you, but it's drawn there. So if you look at that circle, for which angles between 0 and 2 pi, so in other words, once around, is the sign -1. Now, what's our definition of sine? Y over R. If we are in the unit circle, isn't our radius 1? So we really just want to know then, where is y -1? Would you agree with that? So around the circle, get that hat on. Where is y -1? Right down here, 3 pi over 2. Very, very good. Remember, these are how our circle is labeled. And we're going all the way around. We want to consider all the options where y is -1. That's easy enough. All right, how about cosine? Can you figure out where cosine is -1? Now, cosine is x. So where does that happen? Right here? Isn't this where x is -1? So the answer to B is pi. Now what about tangent? This one is a little bit trickier. What's our definition of tangent? Y over x. So we need y over x to be -1. Yep. Now, doesn't that mean that y and x have to be the same number, but one of them's positive and one of them's negative? Doesn't that mean we're automatically going to be in quadrant 2 or 4? And what is the angle that has these two numbers the same? Pi over 4, right? Pi over 4 is your angle where they match, but I need to be in quadrant 2, so that one is 3 pi over 4. And then I could also be in quadrant 4, and that one is 7 pi over 4. Bingo, there you go. So that one has 2 answers. C has 2 answers, 3 pi over 4 and 7 pi over 4. Everybody follow the logic as we work our way through that? Good. All right, if the cosine of 280 is approximately 0.174, estimate the cosine of 260. Okay, obviously that's not one of my special angles. So here's 270, right? 280 would be right here, I mean, more or less. Are you good with that? And if this is a unit circle, then my x coordinate is 0.174. Unit circle. Does that make sense to you? Now, what do you think about 260? Now think about that for a second. 260 is right here. Negative 0.174. Wouldn't these two triangles be the same? Only 260 is in a negative x area and 280 is in a positive x area. Very good. Okay, that's wonderful. Let's go on to our notes, 3.3. We've memorized Kristen already talked about, that sine theta is x over r. Oh, sine. Y over r. Yep, sine is y over r. I was still thinking about cosine. Sine is y over r. And cosine is x over r. So we could multiply by r, and then this would say r sine theta equals y, and r cosine theta equals x. Would you agree with that? Just doing a little bit of like arithmetic there. So we're used to writing ordered pairs as x comma y. Well, now we can write ordered pairs as r cosine theta, comma, r sine theta, because this is x and this is y. Nothing hard there, just a different way of looking at ordered pairs. So when we go down to example 1, our radius is 4, so the radius is 4. And we're looking at point Q. What is the right angle, do you think, for point Q? Think of your unit circle. Is it pi over 3, 5 pi over 6, 2 pi over 3, or we got some negatives thrown in there too. So what do you think? The angle is clearly 2 pi over 3. And so the answer is C. Your radius is 4 and your angle is 2 pi over 3. Can you make the radius negative like that? You can. But that is a very special circumstance and not necessary in this problem. Points are defined like this. And if we adjust it with negatives, then we change that point. So our point has a radius of 4 and an angle of 2 pi over 3. So the answer is C. We're not messing with it.
Where would point D be on the circle?
It would be, cosine is already a negative number. Cosine 2 pi over 3 is a negative number. So if you multiplied it by a negative radius, it would turn it into a positive number. So now x would be positive. And I need x to be negative.
So it would just be point P.
No, because sine 2 pi over 3 it is also positive. Yeah, it would have the same coordinates as point P. Yeah. All right, let's look at number 2. The circle and the line intersect at points R, the origin, and P. If the coordinates of P are 6 root 2, negative 6 root 2, what is the value of R? Okay, so our point is right here. This is point P. And we know that P is R cosine theta, R sine theta. That's P. But we also know that it's 6 root 2, negative 6 root 2. Any idea about what theta has to be? The angle is going to be a 45-degree angle, but it's in quadrant 4. So that won't be 45 or pi over 4. That will be what? What is the quadrant 4? 7 pi over 4. So theta, so R cosine 7 pi over 4. R sine 7 pi over 4. So let's make sure everybody's understanding that. These two numbers are the same. There's only one place, one angle, where x and y match, and that's 45 degrees. Right? Well, any version of 45. Or pi over 4. This version needs to be in quadrant 4. So that angle is 7 pi over 4. Okay?
How can we prove that like the root 2 means that it's 45 degrees?
With but that's not what proves it's worth it. These are the same values. X and Y are the same. X and Y are only equal with a 45-degree angle. Yeah. So it really doesn't have anything to do with the root 2's. Those could be root 3's, Cole. Those could be root 3's. And as long as they're the same, the angle's 7 pi over 4. Yeah, those are down there. Sine is negative down here. Now, my job is to figure out what the radius is. Do I know what this is? What's the cosine of 7 pi over 4? Think of your unit circle. What is the x value on your unit circle at 7 pi over 4? So right here, 7 pi over 4 on my unit circle. What are the coordinates of that point? Root 2 over 2, negative root 2 over 2. That is your cosine. Remember, on the unit circle, cosine is x, because r is 1. So this, right here, is root 2 over 2. So r times root 2 over 2 has to be 6 root 2. Root 2 over 2 is the cosine. The cosine times the radius has to give me my x coordinate. So can I figure out r from that? I sure can. So if I times by 2, I'm going to get root 2r equals 12 root 2. Looks like r is going to be 12. And I don't even need to do this one. I can if I want, but the answer is going to be the same. R is the same for both points. Declan?
If the radius is 12, how are we allowed to use like this for a unit circle, like to find the cosine?
Okay, now, okay, all right. First of all, let me just back up. Don't overthink it. Is cosine x over r? So x is going to be r cosine theta every time, right? If my radius is 1, now I'm not talking about this point anymore. I'm talking about letting my radius be 1 to get my cosine value. Okay? If I put it in a circle with a radius of 12, then the x and the y are still going to represent sine and cosine, and they're still going to be root 2 over 2 for the x and y individually, not times the radius. The cosine, if you type in on your calculator, cosine 45 or cosine pi over 4, it doesn't care what size the circle is, that's irrelevant. The cosine of pi over 4 is root 2 over 2, period. Doesn't matter how big or small the circle is, okay? Because the size of the circle gets canceled out when you put your x coordinate. If your circle is bigger, your x coordinate is going to be bigger. Like right here, this x coordinate's bigger. Agreed? So r cosine theta equals 6 root 2. Well, I just showed that the radius was 12. So if I divide by 12, what does the cosine end up equaling? Root 2 over 2. Always. That will never change. It'll never change. You talked about this in geometry. If this triangle is 4, 5, 6, the tangent of that angle is 5 over 4. If I double the size of the triangle, 8, 10, 12, the tangent of that angle is still 5 over 4. The size of the picture, the size of the circle does not change in trigonometric functions. Okay? So forever and ever, long, I know I'm doing on and on, but forever and ever, the sine of pi over 6 is 1/2. The cosine of pi over 4 is root 2 over 2. Those values are indisputable. They're in a table. They don't change. Okay? So it's easiest to pull those values off the unit circle, because then cosine is just the x coordinate. If I pull it off a bigger circle, then cosine is x over r, and I have to deal with that. So That's why we emphasize unit circle, because it gives us all of our cosines and sines for the special angles. Okay? All right. So we figured out R was 12. Did everybody follow all that? So we've already figured out that X and Y can be expressed this way. They told us this was X, so our cosine had to be 6 root 2. But we knew our angle, we figured out our angle was 7 pi over 4. We know the cosine, so we just plugged it in and solved. Let's try the next one. Is it the same thing? Nope, this is easier. What's the cosine of 0? Oh, whoa, 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 what's cosine? Cosine is x. So the cosine of 0 is 1. What's the sine of 0? 0. What's the cosine of pi over 2? Cosine's x. What's x straight up? 0. Sine pi over 2. 1. Cosine pi. Now we're left. Cosine is x. What's the cosine over there? -1. How about the sine? 0. Straight down. Cosine x. 0. Sine -1. That won't change. Ever, ever, ever. A large portion of this course requires that we can find numerical values for functions involving sine, cosine, and important angle values. The angles we've been working with are multiples of pi over 4 and pi over 6. Now we're going to put all this stuff together, and we're going to start answering some questions. So it goes through a bunch of stuff there. All right, let's go ahead and move to the next example and see if we can figure out what all that stuff means. Okay, we go to math together. We'll get our seating chart here in a second. Let's do example 4 and see if we can figure it out. All right, so here's my unit circle. And I got some points here. Okay, now when I look at that point, can you tell me how big this angle is right here? Well, it's a 30, but remember we gotta be in radians, so we won't say 30, we'll say pi over 6. So this is a pi over 6 angle, okay? Now, remember, the beauty of the unit circle is all of the corresponding pi over 6's are going to have exactly the same coordinates. In other words, they're going to have the same sine and cosine except for negatives. Would you agree with that? Just for fun, let's see if we can label the pi over 6's. Okay, so this is pi over 6. What's this one over here? 5 pi over 6. Beautiful. How about this guy? 7 pi over 6. And the last one? Wonderful. You doing that without your unit circle? Very good. Very, very good. Okay, so this is Q and R and S. And you need to fill in the points. Well, I kind of already done it on the board. At Q, the angle measure, as you said, is 5 pi over 6. And the point is negative positive. R is 7 pi over 6. And the point's negative negative. And S is 11 pi over 6, positive negative. Pretty easy? Yeah, not too bad. Now, when you do the next one, example 5 is exactly the same thing, using now an angle that is pi over 4. So do the same thing, gonna use your starting angle as pi over 4. And when you're done, go ahead and do example 6, because it's the same thing, it's the pi over, or yeah, the pi over 3 angle. Are able to fill in most of these little tables without looking at your unit circle. You're able just to do it. Good. For example 5, what were the angles for Q, R, and S? For example 5, Q was 3 pi over 4, R was 5 pi over 4, and S was 7 pi over 4. And then you had the ordered pairs down below, which is negatives for them. What about, for example, 6? Q was 2 pi over 3, R was 4 pi over 3, and S was 5 pi over 3. And then look what's down there at the bottom. Oh my gosh, he drew it. But the key here, and it's something I've been saying since the beginning, as long as we know the coordinates of our important angles in quadrant 1, we're good to go. You just did it, filling in those tables. Perfect. All right. Example 7. Here's where it's right here. This is what we've done all this for, so that you can actually give me sine and cosine values for all of these special angles. He has drawn quadrant 1 for you. Remember, every version of pi over 6 is going to have an x coordinate of root 3 over 2 and a y coordinate of 1/2, right? X is cosine. So every cosine of a pi over 6 is going to be either positive root 3 over 2 or negative root 3 over 2. Every sine of a pi over 6 is going to be either 1/2 or negative 1/2. Does that make sense to you? So start filling them in. Example 7. Start filling them in. Try to do it with only the unit circle at the top. See if you can do it just based on quadrant 1. Yeah, turn the page. Yeah. Oh no. Right here, we're doing those notes right at that bottom. Before it goes in. We're not gonna get them all, but I'd like you to have at least the first 3 done. We'll talk about them. And while you are doing that, I will tell you okay. We got lucky. We are in section C, which I think is over in the junior area. Section C, and we're the top 2 rows. Now we have to share that second row with Miss Ludington, but we're in the top 2 rows, okay? When we go to communion, he sent me an email to make sure we did this right. When we go to communion, we start at the top. So whoever sits along the wall, you're going to be first in our section to go to communion. And you're going to come down the center aisle and then back up the middle of the aisle of the junior section. Are you following what I'm talking about? Okay, that's what we're gonna do. All right, let's run through these and then it's gonna be time to go. So sine 2 pi over 3. Who has an answer you think is right for the sine of 2 pi over 3? Okay, who has an answer even if you don't think it's right? Bennett?
Root 3 over 2.
Root 3 over 2. And that would be positive, Bennett, because 2 pi over 3 is in quadrant 2, and y is positive in quadrant 2, and y is sine. Okay, how about cosine 5 pi over 4? Gabby? Negative root 2 over 2. Sine and cosine are both negative in quadrant 4, quadrant 3, because x and y are negative in quadrant 3, right? And finally, C, this last one we're gonna have time for. Who got something you think for C?
Root 3 over 2.
Positive root 3 over 2, because 11 pi over 6 is in quadrant 4, and x is positive in quadrant 4. Perfect. We'll pick up there, finish up that tomorrow.
Good enough?
Yeah, once you gather all your stuff up. Gather